Good morning friend. Today I am going to explanation about the expression for the effective resistance when three resistors are connected in series and parallel. So this is one of the important topic in current electricity. So before going to talk about this topic, I will give you a little bit introduction about what is current, what is resistance and what is potential difference. So current is nothing but it's a flow of electric charges, and resistance is what which opposes the flow of current, and the potential difference between any 2 points is nothing but it's a amount of work done in bringing a unit positive charge from one point to the another point. So now we are going to give a derivation between these three, that is I, V and R. So for that purpose here there is a diagram is there here in which the three resistance R1, R2 and R3 are connected in series, and here current I is flowing through them. Here three resistance R1, R2, R3 are connected in series as shown in the figure. V1, V2, V3 are the potential difference across V1, V2, V3 are nothing but a potential difference across R1, R2 and R3. Here I is the current flowing through them. Applying the Ohm's law, we know that according to the Ohm's law, voltage is equal to the product of current and resistance. Here we are applying the voltage law, that is Ohm's law across R1, across R2 and across R3. So that's why V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. So we know that in series we can write total potential difference is equal to potential difference across V1, across R1, across R2 and across R3. So we can write V1 plus V2 plus V3. So we know that we can write IRS. S is nothing but a for the series combination. V is nothing but a voltage, and voltage is nothing but it's a product of current and resistance, is equal to IR1 plus IR2 plus IR3. Here if you take out the common I, so both the sides I get cancelled. We will get RS is equal to R1 plus R2 plus R3. So this is the effective resistance when three resistors are connected in series. Now when three resistors are connected in parallel, so that time what will be the effective resistance? Here R1, R2, R3 are connected in parallel. So three resistance R1, R2, R3 are connected in parallel as shown in the figure. The potential difference across each resistance is V. I1, I2 and I3 are the three currents which are flowing through them. Now applying the Ohm's law across R1, R2 and R3, then we know that V is equal to I1 R1, and that is equal to I2 R2, and that is equal to I3 R3 in parallel combination. So in series combination it will be potential will be V1 plus V2 plus V3, but in parallel combination all the potentials across R1, R2, R3 are equal. So that's why I1 is equal to V by R1 we can write, I2 is equal to V by R2 and I3 is equal to V by R3. So in parallel I total current is equal to the I1 plus I2 plus I3. So current is nothing but it's a ratio between the voltage and resistance. So V by RP. P is nothing but for the parallel combination is equal to V by R1 plus V by R2 plus V by R3. Okay. So now if you take out the V common, both the sides V get cancelled. Then we will get 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the effective resistance when three resistors are connected in parallel. Thank you. For more videos, subscribe my channel Physics.